Hi, welcome to my video on rational functions, and this one is going to deal with the vertical and the horizontal asymptotes of rational functions. A rational function is defined as the f of x equals the d of x over the e of x, where d of x and e of x are polynomials and e of x is not a constant. So the vertical asymptotes is when the e of x, which is the denominator, is equal to 0, and we solve it. And also, the d of x and the e of x have no greatest common factor. There's no common factor is removed. So let's look at the f of x equals 1 over x. So if we let the denominator equal to 0, so that means the asymptote is when x equals 0, because if we have a 0 in the denominator, 1 divided by 0 is undefined. So the vertical asymptote here, and I'll do it as a broken line, is the y-axis, because that's when x is equal to 0. In this one, the f of x equals 1 over x minus 2. So if we let x minus 2 equal 0, x is 2. So the vertical asymptote, x is 2. This is 2 right here. Let's put a 3 there. So we come down through, and this is a vertical asymptote. Notice it's a broken line. So no value of x equals 2. All points on this line will have x equals 2. So it's a vertical asymptote. The graph will have none of these points on this line, which is a vertical line, x equals 2. And the third one, the f of x equals 1 over x plus 3x minus 2. So x plus 3 times x minus 2 is equal to 0. That means x plus 3 is equal to 0, or x minus 2 equals 0. So x is negative 3, or x is 2. So this one is a quadratic. If you multiply those two binomials, you get an x squared. And an x squared is a quadratic, and a quadratic has two x-intercepts, maximum of 2. In this case, we have 2. So x is negative 3. So let's make that a negative 4. So negative 3 is a vertical asymptote right there. So as x equals negative 3, x equals 2. So let's make that a 3 and go down here at 2. So this one has two vertical asymptotes at x equals 2 and x equals negative 3. And again, this one, we let x plus 2 times x minus 3 equals 0. So x plus 2 equals 0, or x minus 3 equals 0. So x equals negative 2, or x equals 3. So x is negative 2. So that's vertical asymptote here, and there's a broken line. And that's x equals negative 2, and x equals 3, which is vertical asymptote. So that means this graph will not have any points which have the x-coordinates of 2 or the x-coordinates of negative 2, or the x-coordinates of 3. So that's the vertical asymptote. When you let your denominator equal 0 and solve it, you can't have those values because it's undefined. And what about the horizontal asymptotes? Well, if you got the f of x equals to d over x, the d over x divided by the e over x plus k, then the horizontal asymptotes is the f of x equals k. And also remember, the f of x is a y. So we could have y equals the d of x over the e of x plus k. So the f of x is just a y. So this is a y or the f of x. So what value of k? So we got a plus 0. 0 is on the end. So the horizontal asymptote is y equals 0. And y equals 0 is, this is a horizontal asymptote right here. That means that the graphs will come in and approach this horizontal asymptote and not cut through it. Or it could come up this way and not cut through, or it could come up this way, or it can come down here and go along here. So that's a horizontal asymptote, is when y equals 0. And if you think about it, as the values of x get larger and larger and larger, so if x gets larger and larger and larger going to infinity, 1 over x goes to 0, which is this number here. And as x gets larger and larger and larger, 1 over x goes to 0, so the graph goes to 2. So the horizontal asymptote is y equals 2. So we make that a 1, 2, 3. So the horizontal asymptote is right here. And in this one, again, we got negative 1 over x. As x goes to infinity, it's larger and larger and larger. This approaches 0. So that means y approaches negative 1. And approaches, let's say that's negative 2. So negative 1 is right there. So this is y equals 2. This is y equals 0. And again, we know, or should know, that's the x-axis, that's the y-axis. So this is y equals negative 1. And in this one, again, notice we have a 0 on the end. As x goes to infinity, then the 1 over this number going to infinity, infinity times infinity is infinity squared. So it goes to 0. So there it is. The vertical asymptote, sorry, the horizontal asymptote is y equals 0. And it's all based on this 1 over this number. And you're going to see just different ones, but because the denominator has the values of x larger than what's in the numerator, then it goes to 0, or goes to the asymptote, horizontal. And let's look at a graph, state for each. So for each of these, I'm going to have VA, which is the vertical asymptote, and HA, which is the horizontal asymptote. So the vertical asymptote is what the graphs are approaching. So the vertical asymptote in this one is x equals 0. That's a 2, negative 2, that's a 0. So the vertical asymptote is a vertical line, x equals 0. The horizontal asymptote, the graph is getting closer and closer to 0 here, going to infinity. As x goes to infinity, gets larger and larger, the y value goes to 0. As x goes to negative infinity, then the y value gets closer and closer to 0. So it's y equals 0. And in this one, the vertical asymptote is here, going up and down. So that's x equals 3. And the horizontal asymptote is sideways. So that's y equals 1. And number 3, the vertical asymptote here is up and down. So that's negative 1, negative 2, negative 3, negative 4. So x equals negative 4. And the horizontal asymptote, negative 1, negative 2, is y equals negative 2. So the vertical asymptotes are vertical line up and down. Horizontal asymptotes goes like that. Notice as you go to infinity, as like this, it's approaching the negative 2. As you go to negative infinity, is approaching the negative 2. Number 4, we got 2 vertical asymptotes. Negative 1, negative 2, negative 3. And this one here is 1, 2. So that's the 2 vertical asymptotes. And the horizontal asymptote, as you go to infinity, that's going to 0. So that means y equals 0. Number 5, we have a vertical asymptote is negative 1, negative 2. So x equals negative 2. And the horizontal asymptote, as you go to infinity, as x gets larger and larger, you're going to negative 3. As x goes to negative infinity, x is getting negative infinity going this way. It goes to y equals negative 3. So that's the review of the vertical and the horizontal asymptotes that we're going to deal with in rational functions. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.